Hello, good evening, students. So let us continue the MCQs of dual nature of radiation and matter. Look at this problem, that is the 11th one. When a metal surface is illuminated by the light of wavelength, what's the wavelength? First wavelength is given, that is 400 nanometer, that is lambda 1. And the second wavelength is lambda 2. The maximum velocities of the photoelectrons ejected are V and 2V. This is V1, this is V2. Now, they are expecting you to find the work function of the metal, that is phi, where h is the Planck's constant and c is the velocity of light in air. Now, they are not substituting in terms of h and c. So you have to keep this hc as it is in the solving the equations. Don't substitute for h and c. Be very careful in that. Be very careful in that. You know, the Einstein's equation is equal to total energy is equal to the work function plus the kinetic energy. The kinetic energy can be taken as half times of m into v square. Half times of what? M into v square. What is the total energy formula? Hc by lambda 1 equals to work function plus half times of m into v1 square. Or you can do like this. Of m v1 square is equal to what? Hc by lambda 1 minus the work function of m v2 square is equal to hc by lambda 2 minus work function, because work function is same. Now you can call this equation as 1. You can call this equation as 2. Now if I divide this equation 1 and 2, if I divide this equation 1 and 2, what you will get? Half m will get cancelled out. So v1 squared by v2 squared is equal to h into c by lambda 1, that is 400 nanometer, minus work function by hc by lambda 2, that is 250 nano, minus work function. What is v1? V. What is v2? 2v. So it is v divided by 2v whole square is equal to this RHS term as it is. This and this will get cancelled. 1 by 2 whole square will be 1 by 4. So this will become 1 by 4, this denominator as it is. If I do the cross multiplication, what I'm going to get? If I do the cross multiplication, hc by 250 nano minus work function is equal to 4 times of numerator. So 4 times of hc divided by 400 nano minus 4 times of work function. Shift this term to this side. What will happen? Plus 4, 5 minus 5. It is 3, 5. hc, 4 hc by 400 nano. hc by 100 nano minus hc by 250 nano. 250 nano. So 3, 5. What is the common term? hc divided by nano, that is 10 power minus 9. In the bracket, we'll get 1 by 100 minus 1 by 250. Take out the LCM and simplify for 5. So 35 is equal to HC by 10 power minus 9. What's the LCM between 100 and 250? You can take 500. So this will be 5 minus 2. 5 minus 2 will be 3. This 3 and this 3 will get cancelled out. So you will get HC divided by 10 power minus 9 into 1 by 500. That is 1 by 5 into 10 power 2. Or 1 by 5 times of HC into 10 power plus 7. Isn't it? Minus 9 plus 2 will be minus 7. If it comes to numerator, it will be 10 power 7. So you can tell which is the right option. 1 by 5. Do one thing. You simplify 1 by 5. 1 by 5 is what? 0.2 HC into 10 power 7. Or you can take it as 2 times of HC into 10 power 6. So 2 times of HC into 10 power 6. So which is the right option? Option A, right? 2 times of HC into 10 power 6. Okay. Look at this. Work function of the metal A and metal B are in the ratio 1:2. What is the work function of the metal A? Work function of the metal A by work function of the metal B. They are in the ratio 1:2. Frequency incident or F1 is F. Second frequency is 2F. They are expecting you to find the maximum kinetic energy of the photoelectrons. Maximum kinetic energy of the photoelectrons. Ke1 by Ke2. F is the frequency greater than the threshold frequency of A. 2F is the greater than the threshold frequency of B. Now, how to simplify this? How to find the kinetic energy ratios? Now, frequency is in the ratio F1 by F2, 1 by 2, right? F divided by 2F, 1 by 2. You know that energy is directly proportional to frequency. So what will be the energy ratio E1 by E2? That is also 1 by 2. Energy ratio is also 1 by 2. Work function ratio is also 1 by 2. Work function ratio is 1 by 2. Energy ratio is 1 by 2. You know that kinetic energy is directly proportional to total energy minus the work function. So kinetic energy is directly proportional to total energy minus work function. So proportionality I'm talking. So work function is in the off ratio. Energy is in the off ratio. Definitely kinetic energy must be is also in the off ratio. That is 1:2. I hope in the last class, I think I derived this. Now you can take it is in the same ratio. That is 1:2. Yeah. 13th one. When a point source of monochromatic light is at a distance of how much? 0.2 meter from the photoelectric cell. Cutoff voltage. Cutoff voltage means stopping potential. What is stopping potential they have given? 0.6 volt. What is the saturation current I? 18 milliampere. Now, if the same source is placed at 0.6 meter away, how the photoelectric cell is going to change? Please remember, photoelectric current I is directly proportional to the intensity. Photoelectric current is directly proportional to the intensity. But intensity is inversely proportional to the square of the distance, no? Intensity is directly proportional to 1 by the distance square. Now, distance is increased from 0.2 to 0.6. 0.2 to 0.6. So, distance is increased by how many times? Distance is increased by how many times then, Lakshmi? 3 times, no?
Yes, sir.
Yeah. If distance is increased by 3 times of d, can you tell me the photoelectric current increases by how many times?
Sir, it is inversely proportional, no, sir?
Yeah, it becomes 1 by 9.
Yes, sir.
So it becomes 1 by 9 times of what? Initial current. What's the initial current?
Sir, 18 milliampere.
18 milliampere, right?
Yes, sir.
So 18 milliampere. So what will be I dash then? It will be 2 milliampere, right?
Yes,
So
sir.
saturation current has to come to 2 milliampere. But look at the option. This saturation current is 6 milliampere, which is not possible. This saturation current is 18 milliampere, which is not possible. Correct? No?
Yes, sir.
Yeah. Now you have to talk about stopping potential then. Now please remember, stopping potential is independent of distance. It does not depend on distance. Stopping potential not depend on distance. When stopping potential not depend on the distance, whatever the initial potential, stopping potential, they have given 0.6 volt. You should get 0.6 volt only. So which is the right option? The second one is the right option. So the stopping potential will become 0.6 volt. Yeah. This is important. In a photoemissive cell, existing wavelength is lambda. Fastest electron has speed v. Existing wavelength is changed to 3 lambda by 4. It is changed to how much? Three lambda by 4. 3 lambda by 4 means wavelength is decreased or increased. It is 1 lambda. This is 3 by 4 lambda. Three by 4 lambda means 0.75. So wavelength has decreased. Wavelength has decreased. Now they are expecting you to find what is the speed of the fastest emitted electron V dash. If the wavelength is changed from lambda to 3 lambda by 4, how the velocity is going to change, you have to discuss. You have to discuss. Yeah. What's the equation for kinetic energy? Total energy minus work function. What is kinetic energy formula? of mv square. So total energy minus work function. What is V squared from this equation? Total energy 2 times minus 2 times of work function divided by the mass. M. What is V then? Root of 2 times of E by M minus 2 times of phi by M. Isn't it? Correct, no? Yeah. So this is the basic formula for the velocity. Yeah. Now given, what is the given condition? Wavelength is changing to 3 times of lambda by 4. 3 times of lambda by 4. So clearly this tells energy has to increase by 4 by 3 times of E, because energy is inversely proportional to wavelength, hc by lambda. E is hc by lambda, no. If E is hc by lambda, how energy and wavelength are related? Inversely proportional. So E dash will become 4 by 3 times of E. Four by 3 times of E. Now, similarly, can you write it for V dash now? Root of 2 times E. What is E? 4 by 3 E, right? By M. Minus work function remains same, that is 2 phi by M. 2 phi by M. Now, can I take out 4 by 3 as common? So it will be 2E by M minus 2 phi by M. Whatever the common I am taking 4 by 3, it is not there in this second term. Since it is not there in the second term, I am going to write that in the denominator. If common term is not there, then the term should be written in the denominator, no, Dhanlakshmi? So what will happen to V dash? 4 by 3 root. I will take it as 4 by 3 whole power 1 by 2 into root of this 2E by M minus 2 phi by M into 3 by 4. V dash, this 2E by M minus 2 phi by M into 3 by 4. So 3 by 4, if you multiply, it will be 0.75. 2 ones are 2 twos are 3 by 2. It becomes 3 by 2. So 3 by 2 times here 2 times. This is 2 times. This is 3 by 2 times. 3 by 2 means 1.5. Actually, this value has decreased. So this value actually it has decreased. If the second term is decreased, then the difference should increase, no? This entire term should increase, no? If this is increased, then obviously V dash should be more than 4 by 3 times of 1 by 2 times of initial speed. So initially 2 phi by M is there. If it comes to be 3 by 4 into 2 phi by M means it has decreased. 3 by 4 means 0.75. It has decreased. If the second term has decreased, if this second term is decreased, then the difference has to increase. If this difference term is increasing, then this V dash should be more than the initial speed. V dash should be more than the initial speed. So V dash should be more than 4 by 3 whole power 1 by 2 into V. Into V. So can you tell me which will be the right option then? Greater than. Greater than 4 by 3 whole power 1 by 2 times of V. Option D is the right answer. ಸ್ವಲ್ಪ lengthy, I think you can manage this. Actually, this was asked in the previous year. Yeah. Now they are asking you to find the speed of the electron having the wavelength of 10 power minus 10. What is the de Broglie wavelength of an electron? De Broglie wavelength basic definition is given by h divided by mass into velocity. H divided by mass into velocity. So what is velocity from this equation? H divided by m into lambda. So V is equal to, what is H value? 6.625 into 10 power minus 34. What about the mass of the electron? They are talking about which particle? Electron. What is the mass of the electron? (9.1 into 10 power minus 31. What is the wavelength they have given? 10 power minus 10. 6.6 divided by 9 means 2.22 divided by 3 into 10 power. Minus 31 minus 10 will be minus 41. Minus 41 it comes up. So plus 41. Plus 41 minus 34 will be 7. 2.2 by 3 is, you will get 0.71. Approximately I'm talking 10 power 7 or 7.1 into 10 power 6. What's the unit of velocity? Meter per second. So option A is the right answer. Yeah. Look at this problem. There are two particles. One is called the electron. The another one is the photon. They have the same wavelength. Wavelength of the electron is equal to the wavelength of the photon. What is P? P is the momentum of the electron. E is the energy of the photon. Then what is the ratio of P by E? How to calculate the de Broglie wavelength of the electron? It is h divided by mass into velocity. That mass into velocity is momentum. That is the momentum of the electron. You know the energy of the photon is given by the formula hc by lambda. So what is lambda then? hc by E. So the wavelength of the photon can be taken as hc by E. Wavelength of the photon is given by hc divided by E. So h and h is going to get cancelled out. Do the cross multiplication. 1 by c is equal to p divided by E. So what is the value you got for p by E? P by E value you got it as 1 by c. So what is the value of c? That is speed of light. 3 into 10 power 8. What is 1 by 3? 0.33 recurring. So it becomes 10 power minus 8. Or you can take this as 3.33 into 10 power minus 9. So option B. It is in SI unit only. Yeah. This is similar to that itself. What is the energy of the photon equal to? Energy of the photon is equal to the kinetic energy of the proton. Energy of the photon is equal to kinetic energy of the proton. Energy of the photon is given as E. What is the de Broglie wavelength of the proton? Is lambda 1. Lambda 2 is the wavelength of the photon. Then they are expecting the ratio lambda 1 by lambda 2. Lambda 1 by lambda 2. Yeah. Can you tell me the de Broglie wavelength for the proton? For the proton, it is lambda 1. You know that de Broglie wavelength is given by the formula lambda is equal to h divided by root of 2 times of Ek, where Ek represents the kinetic energy. This is for proton. What is the wavelength of the photon? That is lambda 2. That is h divided by momentum. What is that momentum? P. Or you can take it as hc by lambda. So lambda will be is equal to hc divided by E for the photon. hc divided by E. This is for photon. Now you can take up lambda 1 by lambda 2. Lambda 1 is h divided by root of 2m. I will take it as E only because kinetic energy of the proton and the energy of the photon are equal. So I will take the kinetic energy of the photon as E. H divided by lambda 2, that is Hc divided by E. Now you can simplify further. What is lambda 1 by lambda 2? So what is lambda 1 by lambda 2? H divided by root of 2me into E divided by Hc. So H and HR get cancelled out. So lambda 1 by lambda 2 is equal to, this E can be taken as root E into root E divided by root of 2me. So 1 root E will get cancelled out. So square root of E divided by 2m. So wavelength ratio lambda 1 by lambda 2 is directly proportional to root of m. So lambda 1 by lambda 2 is directly proportional to root of E. Root E is directly proportional to E power 1 by 2. E power 1 by 2. So what is the ratio? Lambda 1 by lambda 2 is equal to root of E, or you can take it as E power 1 by 2. Got it? Yeah. Yes. What is the de Broglie wavelength of an electron of energy? Energy is given. How much? 80 electron volt. So what is the potential then? If energy is in electron volt, potential should be in volt. So potential is 80 volt. They're asking to find the de Broglie wavelength for that electron. Now you can use the formula for the electron as H divided by root of 2mq into V, but don't use this formula for the competitive level. I hope I've given one formula in the synopsis for the wavelength of the electron, that is 12.1 or 12.2 divided by root V. This is the shortcut formula what we have given for electron. Approximately 12.1 or 12.2 you can use. If you know the potential, you can use directly 12.2 divided by root V, only for electron I am talking. And also I hope I have given for alpha particle, for proton also. For electron, it is 12.2 divided by root V. What is V they have given? Root 80. What is root 80? 9. Approximately 9. Root 81 is 9. So what is 12 by 9? 4 by 3. 4 by 3. What is 4 by 3? Approximately equal to 1.3. So this value, if you substitute in terms of volt, this wavelength should get in terms of what? Angstrom. 1.3 angstrom, close to what? 1.4 angstrom. So option D is the right answer. Yeah. I hope you can manage this problem then, Lakshmi, because it is a direct problem. One particle is electron, the another particle is proton. Kinetic energy is same for both the particle. How much it is? (10⁻32 joule). So what's the formula for the de Broglie wavelength? Lambda is h divided by root of 2m into Ek, where Ek represents the kinetic energy. Since kinetic energy is given as same for both electron and proton, this kinetic energy is constant now. How de Broglie wavelength and mass are related? De Broglie wavelength is inversely proportional to root mass. So, wavelength of electron to that of wavelength of proton is root of mp divided by me. This is the expression. But you know that mass of the proton is very much large compared to the mass of the electron. Mass of proton is more. Mass of electron is less. How de Broglie wavelength, lambda and mass are related? Inversely proportional, no. If mass is more, wavelength will be less. So mass of the proton is very more compared to mass of the electron. This implies wavelength of the proton is less compared to the wavelength of the electron. More mass, less wavelength. Since mass of the proton is more, wavelength of the proton must be less. So which will be the right option?
Yes, sir.
Yeah, option A. Good. I think you can manage this. They are given with the two particles. One particle is proton, the another one is alpha particle. Alpha particle. Energy is the same. What is the ratio of the de Broglie wavelength? What is the ratio of the de Broglie wavelength? Proton. Proton means hydrogen, 1H1. Alpha particle means two He4. So this clearly tells mass of the alpha particle is how many times? Four times the mass of the proton. Correct? No. Mass is 4 times. What is the de Broglie wavelength in terms of energy? Lambda is equal to h divided by root of 2me. Because in the problem they're telling that the energy is the same. So how de Broglie wavelength and energy are related? De Broglie wavelength is inversely proportional to root of E. Now they are asking to find the ratio. One nimsha. Energy is same, right? Energy is same. So how the wavelength and mass are related? Energy is constant. So lambda is inversely proportional to root mass. Therefore, can you tell me what is lambda p by lambda alpha? Root of mass ulta alpha. So it becomes mass of alpha divided by mass of the proton. This is 4 by 1. What is root 4 by 1? 2. Why 4 by 1? Because mass of the alpha particle is 4 times the mass of the proton. 4 mp by mp. So mp will get cancelled out. So root of 4 by 1. Root 4 by 1 will be 2. 2 by 1. So what will be the ratio?
2:1.
2:1. Yeah. 2:1. Yes. Come to this. De Broglie wavelength of a particle accelerated with this potential is 10 power minus 10 meter. This is lambda 1. This is V1 potential. Now it is accelerated with 600 volts V2. Then what is lambda 2? They are talking for the particle. Now, what is the de Broglie wavelength in terms of potential? Root of 2m q into v. They are talking the particle for the both the cases are same. For both the case, mass and charges are same. So these two are equal. So how lambda and v are related? Lambda is inversely proportional to root v. So what is lambda 1 by lambda 2 then? Root of v2 by v1. What is lambda 1? Ten power minus 10 by lambda 2. What is v2 value? So 10 power minus 10 by lambda 2 equals, what is root of 600 by 150? 4, no. What about root 4? 2. So what will be lambda 2 then? 1 by 2 into 10 power minus 10. What is 1 by 2? Yeah, 0.5. 10 power minus 10 can be taken as angstrom. So 0.5 angstrom. Yeah. De Broglie wavelength of an electron in an orbit of circumference 2 pi r is. What is the formula for the de Broglie wavelength actually? Lambda is equal to h divided by mv. Correct, no? Now you want the answer for the de Broglie wavelength in terms of the circumference. In terms of the circumference. How to get the de Broglie wavelength lambda in terms of circumference? Actually, we have studied the formula for de Broglie wavelength as lambda is equal to h by mv. Now, if I consider an orbit of radius r, what is the circumference of this? 2 pi r. Whenever the wave is moving in the form of stationary waves like this, the wavelength of one wave is lambda. So on the circumference, if there are n number of waves, what is the total wavelength? N lambda. So total length will be n lambda. The total length is on the circumference, no? So what will happen? If n number of waves are formed on the circumference, 2 pi r should be equal to n lambda. 2 pi r equals to n lambda. What is lambda? It is the de Broglie wavelength. So if I assume for the first orbit itself n equals to 1, then it will be 2 pi r is equal to lambda. So what is lambda? H divided by mv. Because you know that lambda is h by mv. So lambda is equal to what? Circumference. So it should be 2 pi r. N value should be always an integer. This n value should be always an integer. Like first orbit, second orbit, third orbit, fourth orbit, like that. So option A is the right answer. Yeah, we can take that number of photons in the next session. That is how to calculate the photons by giving the energy and the photon. Yes. I hope you got this problems based on how we are going to solve on the de Broglie wavelength. So in the tomorrow session, we can take up how the power and the number of photons are related, how to calculate the number of photons involved in the radiation. Okay, I'll stop at this stage. We'll continue in the next session. Thank you, then Lakshmi.
Thank you, sir.